to talk about the medians and altitudes in 5.4. So the first thing we're going to do is say that a median of a triangle is a segment whose endpoints are the vertex of the triangle and then the midpoint of the opposite side. If a triangle, in a triangle that has medians coming from all sides, the point of concurrency, or the point where all the medians meet, is considered the centroid of the triangle. Okay. Now, just like in the other points of concurrency, when we have a centroid, it creates a special relationship. The ratio of segments is 1 to 2, and it's 2/3 of DJ is DC, and then 1/3 of DJ is CG. So we say that the ratio of DC to CJ is going to be 2 to 1. Okay. Now, finding these lengths, we're going to use this 1 to 2 relationship, or this 2/3 of the whole. So if we look at XA, okay, XA is from X to A, it's going to be 8. What's the length of XB? Well, we know that XA, since it's from the centroid to the point, right, from centroid to the point or vertice, XA is going to be equal to 2/3, right, of XB, okay? So if we fill in 8 for XA is equal to 2/3 of XB, okay? And then we would multiply, and if you don't remember, the way we do that is we multiply by the reciprocal, which is 3 over 2. So when we do that, that cancels. So we get 3 over 2 times 8 equals XB, right? And so that's going to be X, or 8 times 3. So 8 times 3 gives us 24, and then we divide by 2, so it's 12. So 12 is equal to XB. Okay, so the entire length is equal to 12. What is AB equal to? Okay, well, AB is going to be 1/3 of 12. So if we say 1/3 of 12, then AB is going to be equal to 4. Okay, and that's how we use that relationship to find the lengths. So go ahead and look at A and try to find the length of ZC if ZA equals 9. And I'll pause for a minute for you to do so. So you probably said that ZA, noticing it is 2/3 also, is equal to 2/3 of ZC. Okay, and so therefore 9 is equal to 2/3 of ZC. Okay, if we go ahead and use that reciprocal relationship, we'll multiply by 3 over 2, and 9 times 3 gives us 27, and divided by 2 is going to give us 13.5. So it looks like CC is going to be equal to 13.5. Okay, and that's using the centroid to find lengths of segments. Okay, the next thing we're going to talk about is the perpendicular segment. A perpendicular segment from the vertex and perpendicular to the opposite side is the altitude. And the altitude happens to be that segment that we often called height. So if you notice, sometimes the altitude can be outside, and it's what we used when we said area of a triangle, remember, was equal to 1/2 base times height. This height right here is actually the altitude that we used for that. So if we have multiple altitudes coming together, the point of concurrency for the altitudes we're going to talk about in a second is actually going to be the orthocenter of the triangle. So we look at this when it says for triangle PQS, is PR a median, an altitude, or neither? Well, by definition, PR is going to be an altitude. Okay, going from the vertex to perpendicular to the opposite side. ask, what is QT? Well, QT goes from the vertex to the midpoint, so QT is actually going to be the median for that one, as it does go to the midpoint. So those are just definitions and identifying. If you look at this triangle, now we have a couple of different ones we need to identify. The first one is segment AD. If you notice, segment AD goes from vertex A and it ends at D, which happens to be the midpoint of CB. So in that case, we're going to say that this one is actually going to be a median by definition. Okay, we look at EG. EG goes from the midpoint of AC to what appears to be the midpoint of AB. So in this particular example, it's neither. However, you may remember that it bears a resemblance to the mid-segment that we did in 5.1. CF will go from the vertex and it is perpendicular to the side AB. And so by definition, that's going to be an altitude of the triangle. Okay, so make sure that you know those definitions and that you can identify um, those particular points. Okay, where the altitudes are concurrent, we just talked about a second ago, is going to be the orthocenter of the triangle. Okay, and the concurrent orthocenter for an acute triangle will be inside the triangle. For the right triangle, it's going to be at the vertex of the right angle. Okay, and for the obtuse triangle, it's going to be outside of the triangle. That's how we're going to find the orthocenter. So the very first step when you're finding orthocenter is to graph the triangle. If the triangle is already graphed, then we can move this way. So just like when we found the perpendicular bisector, you want to find the opposite slope. However, unlike the circumcenter, we're not going to go from the midpoint of the side. Instead, we're going to go from the vertices. So for this one, the opposite slope, we went from B and then straight down. Of course, it's undefined. And then from A. From C, we were going to do the opposite slope from C through AB. So we need to find the slope of this line AB. So it looks like it goes up 1, 2, 3, 4, and over 1. So it looks like the slope of the line AB is going to be positive 4 over 1. So the perpendicular slope for AB then is going to be negative 1 over 4. So from here, we need to actually find the negative slope. Now for negative, I can go positive up and then back 4, or I could go down and forward. So I need to go this way, so I'm going to go up 1 and back 1, 2, 3, 4. So this is going to be my point, and I'm going to draw my line from C and then through that point, and then that's going to give me the altitude or the perpendicular line from C through the side AB. Okay, let me just make that just a little bit thinner so we can see it without being distracted. Okay, and when I do that, I find that all of the points hit right here, which that point looks to be 2, 1, 2, 3, 4. So it looks like the orthocenter is 2, 4 for this particular triangle. So go ahead and try triangle DEF, and then we'll check it together. Okay, so if you found the orthocenter for the triangle DEF, you would see that it hits at 1, 2. Okay, and what we notice is that, again, the orthocenter for a right triangle will be at the vertex of the right angle. So if we look at this one, we notice that perpendicular bisectors are circumcenter. Point of concurrency for all the perpendicular bisectors is circumcenter. Point of concurrency for all the angle bisectors is the incenter. The point of concurrency for all the medians is the centroid, and the point of concurrency for all the altitudes is the orthocenter. So be sure and study those for your vocabulary quiz as well as your test on next Monday. Okay, here are your practice problems. So good luck, and we will check them together on Thursday.